Hey everybody, I want to do a couple of these IXLs with you, J.14, 15, and 16. There's been some questions and I want to clarify because they are pretty easy to do. So let's take a look at our first problem. Our first problem says, worried about going over his storage limit, Steven monitored the number of undeleted voicemail messages stored on his phone each day. And we have a nice table there with our days of the week and our voicemail messages for Steven. According to the table, what was the rate of change between Wednesday and Thursday? And I have my what are the number of voicemail messages per day. So remember, then we're doing rate of change. It's the change in y over the change of x. And this problem tells us right here what's my y and what's my x. So my y is going to be my messages and my x is going to be my days. Okay? My problem tells me that it wants to know from Wednesday to Thursday. So I look at my table and I find on Wednesday there was 9 messages and on Thursday there was 3. So he goes from 9 to 3, which is -6. And then the days of the week is from Wednesday to Thursday, and that's only a change of 1 day. So -6 divided by 1 is -6. So my answer is going to be -6 voicemail messages per day. All right, I'll do one more with you here. So I got my nice little table again, and my question is, according to the table, what was the rate of change between 2007 and 2008? And then it's entries per year. Okay? So my entries in 2007 were 35. My entries in 2008 were also 35. So the change there is going to be 0. My years from 2007 to 2008 is 1. 0 divided by 1 is just 0. I'll do one more since that one was kind of silly. So this time I want to know emails per day from Wednesday to Saturday. So on Wednesday, I had 6, and on Saturday, I had 0. So from 6 to 0 is a change of -6. From Wednesday to Saturday is 3 days. -6 divided by 3 is -2, so my rate of change is -2 emails per day. All right, hopefully that helps with J.14. Let's move on to J.15. All right, so same kind of thing here. Remember that rate of change is the change in y over the change in x. And that's nice on our graph because we can just look at our labels on the side. So remember my y is my vertical and my x is my horizontal. So I'm looking for my rate of change from 2011 to 2013. So in 2011, I'm right there. And in 2013, I'm right here. So I'm going to go up 1, 2, 3, 4. And I'm going to go over 1, 2. So 4 over 2 is 2. So my rate of change is 2 games per year. All right, another one here. I want the rate of change from Tuesday to Saturday in voicemail messages per day. So on Tuesday, voicemail is at 16. And on Saturday, my voicemail messages are at 12. So this time I'm going down. So I go down and look, it's counting by 2s. So I'm going down 2, 4. So that's -4. And I'm going over 1, 2, 3, 4. So -4 over 4 is a change of -1. So there's -1 voicemail messages per day. All right, I'm going to do one more with you here. This time I'm going games per year, 2007 to 2008. In 2007, they won 29 games, and in 2008, they won 32. If you look at our labels, it's counting by 1. So the change in y is 1, 2, 3, and the change in x is 1, and 3 divided by 1 is 3, so it's 3 games per year. All right, hopefully that helps with J.15. Let's move on to J.16. All right, same kind of thing that we just got done doing here. If I look at my question, it says, what is the rate of change? And it wants money per attendee. So remember, it's always y over x. It's always y over x. So I'm going to do vertical first and horizontal second. So I'm going to look for a place where my graph goes perfectly in an intersection. So on this one, if you take a look, that's going perfectly through an intersection, and this one's going perfectly through an intersection. Make sure you're looking at your labels because it looks like this one is counting by tens. So I got to go from one point to the other. So I go up 10, 20, 30, and over 10. So I go 30 divided by 10 is 3. So it's $3 per attendee is the rate of change. All right, again, I'm going to look for what is the rate of change. And it does say I want my answer as a decimal or an integer, and it's hairbands per dollar. So I'm going to look for a perfect intersection again. And it looks like there's one right there, and it's counting up by tens. And there's another one right there, and it's counting over by tens. So this one is 10, 20, 30, and 10. So 30 over 10, again, is 3. So the rate of change is 3 hairbands per dollar. All right, last one here. I want pies per cup of sugar. So if I look, that one's going perfectly in an intersection, and this one's going perfectly in an intersection, and it's counting by ones. So 1, 2, 3, and 1. And 3 over 1 is 3. We have our answer is 3 times in a row. See if this one changes a little bit for us. So perfect. Let's take a look at this one. This one's money per visit. Remember, I want to make sure that I'm picking one that is a perfect intersection. And if you look right here, that is not a perfect intersection, so I cannot use that point. But this one's perfect. And I'm going to follow my lineup and find another perfect one. This one's counting by tens again. So I'm going to go up 10, 20, 30, and over 10, 20. So this one is 30 divided by 20, which is 3 halves. And if you take a look, it doesn't say that I need to have it as a decimal or anything, so I could do 3 over 2. But since I'm talking about money, I'm going to write it as $1.50. Don't forget that rate of change, even when you're using a graph, can be negative. Your graph will be going down instead of up. I hope that helps. Shoot me a Schoology message if you need anything else. Peace.